Hi, good afternoon everybody. I'm Dave and today I'm going to talk to you about managing Kubernetes from Python with an open source project I'm involved with called Kube. So why Kubernetes? Well, Kubernetes helps you do microservices things, and we want to do microservices things because they're better than doing monolithic things. And it might sound a bit faddy to the uninitiated, but it's a sound architectural approach that's gaining momentum. I was going to do a few more slides so I can introduce these guys and talk a bit more about microservices, but when I rehearsed last night after several Guinness, the presentation took longer than before, so I thought I'd cut some slides out. So I'm just going to go straight into the Kubernetes bit, and as a quick sort of straw poll, how many of you guys have come to this talk to just hear a bit more about Kubernetes, or how many of you are using, so yeah, that question first. Oh, okay, wow, so a fair amount in the audience are using Kubernetes, and how many people know nothing about Kubernetes and wanted to know a bit about it? Okay, so it's about sort of like 60-40. What I'll do is I'll rattle through these slides about what Kubernetes is, and we should have enough time. Yeah, so Kubernetes, it's an open source container cluster manager originally designed by Google, and it aims to provide a platform for automating deployment, scaling, and the operations of application containers across clusters of hosts. A container technology most of you would have heard of, and probably all of you have heard of, is called Docker. And it turns out managing containers like Docker, or lots of them, is difficult. So putting containers in touch with one another, having replicas for scale and resilience, allocating to hosts, managing access to storage, managing secrets information is all what Kubernetes helps you do. It's born out of Borg, a system which Google wrote, and it managed them to scale developer productivity massively without the corresponding increase in operational overhead. So the smallest Kubernetes deployment is a cluster. Today, when I demo this, I've got Minikube running on my laptop, which is a super duper single node Kubernetes cluster that you can play with. It's beyond easy to install, and I'd recommend that any of you who are interested give it a go, because it's fun. So here I've depicted one master. It's possible to build a highly available cluster with multiple masters for resilience. It's also recommended that you provision a 3-node cluster at least for production use. So the job of the master is to control activities on the nodes, which might be virtual machines or bare metal. So this is the basic structure of a master, and let's have a look what these components are. So etcd is a highly available distributed key value store, and Kubernetes uses this for persistent storage of all the REST API objects that it exposes. So, for example, what stuff has been allocated to what nodes. And basically, etcd stores the state of the cluster. And the state of the cluster, along with the specification of what you want the cluster to do, are two important concepts in Kubernetes, which we'll look at a bit later as well. So, the Kubernetes API server exposes a REST API. It's used by the systems and the users that are interacting with Kubernetes, as well as the Kubernetes components themselves. So that means that the API client is a first-class citizen in the Kubernetes world. There's no backdoor for the Kubernetes components to use the Kubernetes control plane. Everyone's using the API server. And the API is used to create resources, start and stop stuff, scale stuff, and update things, and so on. The controller manager runs controllers. These are the background threads that handle routine tasks in the cluster. Logically, each controller is a separate process, but to reduce the number of moving parts inside Kubernetes, they're all compiled into a single binary and run in a single process. A controller is a control loop that watches the shared state of the cluster through the API server and makes changes attempting to move the current state of the cluster towards the desired state as defined by the specification. And there's lots of different controllers. There's a node controller responsible for noticing and responding when nodes come and go. There's a replication controller, which we'll talk about a bit later, and that maintains the correct number of pods, which are basically collections of containers, and endpoints controller, which populates endpoints objects and allows us to target pods with service definitions. The Kubernetes scheduler is a complicated and sophisticated piece of software. It's a policy-rich, topology-aware, workload-specific function. It's responsible for maintaining availability, performance, and capacity in the cluster. The scheduler takes into account all sorts of requirements and plans work on the cluster accordingly, and there's clever stuff going on in there. So on the nodes, we have... So there's got to be a runtime, right, because it's running containers. So we've got some sort of runtime. Docker is a common one, but Kubernetes is a container-agnostic control plane, and other container runtimes are supported, like Rocket. Then we have the kubelet, and this is the primary node agent that runs on every node in the cluster. So in Kubernetes, the smallest component or schedulable component is a pod. And basically a pod is a logical host with an IP address, and it runs containers or manages containers. Pod hosts Docker containers and works in terms of a pod specification which is obtained from the API server. And the kubelet ensures that the containers described in those pod specs are running and healthy. And then finally, we have a proxy that takes care of the networking. This runs on every node, and it's configured according to the service definitions that are posted to the API server. And it enables you to expose certain endpoints to either other pods in your architecture or to the edge of the cluster, so that users from the outside can see your services. So putting it all together, what we get is what a Kubernetes cluster might look like. Nodes are controlled by one or more masters with the cluster state stored in etcd, a state which is exposed and updatable via the API server, with the controllers driving the cluster state towards the prevailing spec. And all the time, the policy-rich, topology-aware scheduler maintaining availability, performance, and capacity in the cluster. So we'll just rattle through a bit of terminology for the people who haven't had much contact with Kubernetes. So a namespace provides multiple virtual clusters backed by the same physical cluster. So it means you can group your Kubernetes artifacts inside namespaces. And all resources live in a namespace, and by default, there's one called default. Like I said before, a pod is a logical host in Kubernetes and is the smallest unit of replication and placement. Each pod gets an IP address. So when using multiple containers, you need to take care of port allocation for those containers to make sure you don't get port clashes. Pods contain containers, but typically only one container per pod. That's not a strict rule. There's many a good reason to have what they call sidecar containers, where you have multiple containers inside a pod. Someone earlier speaking said something about, kind of like circumstances where people are using containerized deployments and cramming a whole load of stuff into a container, which, in a microservice environment isn't a great idea, but I understand why people find that useful. So pods can also specify volumes, and this is storage automatically attached to a pod. There's various sorts, and some depend on the cloud vendor that you're running Kubernetes over. So replication controllers ensure that the specification matches state as far as the pods go. They're used for scaling your pods up and down as far as replication goes, but you can also use the replication controller to perform rolling updates. So you get conceptually a zero downtime upgrading of services that you've got running. So there's so it's important to remember that the Kubernetes is a level-based system. So when the replication controller sees that the spec specifies there should be 10 replicas of a pod, and there's only 3, it doesn't go, oh, I'll create 7. It'll ask repetitively for each iteration of the control loop, how many pods are required in the spec versus the state. There's 3, I need 10, okay, I'll start one more, and then it will ask the question again, how many do I need? Well, there's 4, you need 10, okay, I'll start one more, and that's how the controllers work. So, yes, services. Kubernetes pods are mortal. They are born, they die, they get moved around. Each pod gets its own IP address, even those IP addresses can't be relied upon to be stable over time. So this leads to a problem. If some pods, like backends, provide certain functionality to pods that are front ends, then how do they find each other? And this is where services come in. A service, a specification, targets pods and through labels and exposes them at stable endpoints. So I'm going to go into some. So going on to Kube. So Kube is a Python wrapper for the Kubernetes API server. So the guys who've used Kubernetes before, you probably would have obviously used kube control a lot. So this is a way of doing kube control type activities, but in Python. There's a few other of these Python wrappers out there. We decided to write another one. We should have called it yet another Python API, Kubernetes API wrapper. But we didn't want to go through to using a Swagger-based approach. We didn't want to generate code. We also wanted a decent API for supporting the Watch API, which we'll be able to demonstrate soon. So in Python, you basically import Kube. Can you all see this? How's that? Yeah. Yes, so everything you do in Kube is related to a cluster that you want to connect to. So you basically say something like cluster equals kube dot, there's a cluster class which you can construct and you get a cluster object. If your Kubernetes is running on if your Kubernetes API server is running on a non-standard host and port, then you can specify a URL a bit like this. You probably need a HTTP on the front of that, localhost 8001, specifying API endpoint, and then you should be able to get some sort of thing. So yeah, we get the same sort of thing. So once you have a cluster object, there's a bunch of attributes on there. And you can see over here, some of these attributes are represent resources in the Kubernetes API. So here we've got namespaces, and what we call these in Kube terms is we call them resource views. They're basically collections. So you can look at replica sets, and all those things are on here. There's a fairly limited set at the moment. We've got the main ones, and we're obviously always adding more. The good news is these view attributes are iterators. So we can basically create, you can create a list comprehension to say something like RS for RS in cluster.replica sets, and we get a list of replica sets back. There's only one in there at the moment. So, if you wanted to get a replica set, you could do something like this, which is not great, but I'll show you a better way in a minute. And then what we get is what we call a resource item. So on the cluster, there are resource views that give you collections of resources, and then we can get them, because it's an iterator, we can get them and start to play with them. There's also a better way of doing this. You can basically say RS equals RS, equals cluster. Each of these iterators, or each of these views, also have a fetch method where we can say, okay, I want to fetch I know the name of the resource I'm after, so I just want to fetch that. You have to specify the namespace as well when you're trying to get these things to give it a clue. So we can say namespace equals Kube system. It's lunchtime now and the typing's gone to pot. There we go. So now we get an object that we can play with. And we can have a dig around inside this object. Where is that time already? Okay. Yeah, so RS has got an attribute called meta, and meta's got some stuff on it. So we can find out the name of the resource that we pulled back. Actually, we can find the namespace of the resource that we pulled that object back from. We can see what labels are on that resource object as well. And we can actually update labels using this, but I won't do that today. It's some time. What else can we see? Oh yeah, we can actually, there's loads of other attributes on these things. And an interesting one is we can get the specification back for an object. So this returns a dictionary structure that represents the specification of that Kubernetes object. So if you wanted to then later modify the specification inside Kubernetes, then you could take this spec as your starting point and maybe fiddle with that. Another thing we can do is we can get the, raw raw JSON data that represents the object. This is returned as persistent immutable dictionary, so so you can't modify it, and it's just the way we decided to do it inside Kube. Yeah, so another thing that's probably worth mentioning right now is I'm just going to be lazy and cut and paste something because my typing's so awful. There we go. So here what I'm doing is I'm basically just fetching a node, and because I'm running Minikube, my node is, I've got one node and it's called Minikube VM. And I'm getting the metadata's version attribute. And you can see there that it's got a version number. And over time that version number changes because the state of the node is changing and Kubernetes is updating the version. It's saying there's a new version of this resource, so I'm just going to increment the version number. There's not a lot of meaning behind this number, it's just an opaque value that just tells you stuff has changed. And I always think it's important to just point that out, because if you are using Kube, you need to remember that if you're going to operate on the infrastructure, you need to make sure you're working with the most recent version of a resource object. So I said, not recommending you ever use that attribute, just wanted to highlight the fact that you know, things are changing under the hood, and if you basically take RS here, that is an old object that's been around for a while and has likely been updated. Okay, so let's now have a look at doing some other stuff. So I've kind of like done some little pre-canned scripts to show you how you can use Kube to do things. So an interesting thing to do would be, say, to create a replication controller. So if I look, I've got some YAML files I prepared, and if I look at a YAML file that specifies what a replication controller might look like, you can see here the specification says I want one replica. I'm going to, you know, give it a selector and some labels. I'm referencing an image that's already hosted somewhere else out in the cloud, and that's what it's going to spin up, and it's going to make that container listen on a particular port. So that's kind of like standard Kubernetes stuff, and sometimes you might do a kube control -f, you know, and point to a file like that to do that kind of thing. So what I've done is I've got a create RC script, and I mean most of the code in here is comment and it's docstring. So I'm basically loading the YAML file. Can you see that okay as well? And you know, I'm getting that data structure, and then I'm using the cluster object with a context manager, which is quite a cool way of doing it, and Kube supports that. So we're basically getting a cluster, an instance of the cluster class, and we're using it within this context, and we're basically saying call cluster.create, which allows you to create any resource inside Kubernetes, give it the data, give it a namespace, and we'll get a replication controller instance back. That's actually returned as one of our built-in classes, an instance of our built-in classes, replica set item, replication controller item, and I'm going to look at that raw attribute that I was showing you earlier on the command line. So if I just run that, okay, and that fails horribly because it can't find the PyCon namespace. Luckily, if I just quickly show you that in the YAML directory, I've got a namespace YAML file, really straightforward. It just specifies a version, namespace name, and I've also prepared a create namespace script, which is along the lines of the create RC script that we had. It loads the file, uses a context manager to get a cluster instance, and then it calls the create method on the cluster instance with the data to create the namespace. And we don't need namespaces for namespaces, fortunately, so I'll just run that. And then we're just basically printing the output of the raw attribute of the object that was created. Now I can do my create rc.py, and it does the same thing. We've got our replication controller created. So if we just nip over to the old Kubernetes dashboard here, this is looking at my cluster. That's really small, but hopefully you can see that on the big screen. And you can see that my replication controller, Kube Echo, has been created. And you can see my little Kube Echo pod is there running as well. So to be able to see that particular pod that we've created, we need to create a service. We need to target that pod, then we can expose it on the edge. The file, the script that I've written is very, very similar, and I can just run that by explaining Python properly, and I've got one called create service.py, and that creates the service. And now I can actually, there's a little script here I've written. It's basically a tiny bit of bash that will do a curl command on the endpoint that I set up as far as that service goes. If I just execute that, we should see, ta-da, we're hitting that particular pod, and we can see that is the name of that pod that's in here. Cool, excellent. That's really good. We want to see so let's have a look at what we're doing here isn't really massively clever. We're just doing a lot of boilerplate and that you'd have to do if you were going to try and write Python code yourself. What Kube consists of is a bunch of classes and a load of requests code. And we structured that in what we think is quite a nice way. What we're actually looking at is the API servers API. And you can see in here, we're looking at the API services. And somewhere in here, we'll see this service that I just created somewhere. There we go, listening on that port, and so on and so forth. So that's all we're doing is we're getting into that API and getting this information out. Because Kubernetes, as the Kubernetes, or people who have had exposure to it, is really fast moving, it's quite hard to keep up with it in terms of that code base. So there are things in the Kubernetes API under API's extensions, V1, Beta 1, and other places, that's stuff that is new. And if I understand the API versioning, the Google API versioning, or the Kubernetes API versioning policy correctly, eventually these things will get moved into in API V1. But right now, new things like deployments and ingress and all that kind of stuff is in here. So how do we get at that? Kube doesn't have those iterators on the cluster instance. So how do we get at that? Well, we can use a thing called proxy. And if I quickly show you, this. So this is me using the proxy attribute on the cluster. You can see there, you can see here, what we're doing is using the proxy attribute to perform operations on the API. And it provides a get, a put, a patch, and a delete. Sorry, a get, get this right, a get, a patch, a post, and a delete. unfortunately, in the code, sorry, we've hard-coded API v1 in the code. So that doesn't help you get to the extensions very easily, but what you can do is put in a sort of like a prefix on the path. You can put in a relative path to get your call to go into API's extensions v1, v2, and then you can do stuff on all the funky new things. So here I can do things like I can run this. And going back to the code, you can see what's happened here is we've actually constructed a replica set item, which is a Kube class. We constructed an object from the raw data that came back from that get call. So that gives you lots of flexibility in working with new features in Kubernetes as well as standard features. Just to show you how easy it is, I wrote a small script that will scale up that small service deployment that I did. And it also uses all of these things are posted on my GitHub, so you can have a look and have a play. But I've actually got something that scales using our watch capability, so you can basically start to push up the number of replicas inside here. And if I now refresh that, we'll see that there's a load of pods are now starting up inside that. They'll take a while to come up. But as we go back to the command line, we can hit these and we'll start to eventually see different pods taking those requests as more and more of those pods come up. And that's a few lines of Python code. It's really straightforward to do. And likewise, I've got a complementary script in there that will basically tear down those replicas and bring them back down to 1. There's also a script that demonstrates the delete method on the proxy, so keep hitting the microphone. So you can clean up stuff as well. So just going back to the presentation. Very, very quickly. Yeah, so you can download Kube from Bitbucket. It's also pip installable. We're always looking for contributors. We're currently working on, I'm currently working on replacing the HTTP parser we have in there with H11, which is pure Python, and that'll actually improve some of the structures inside the watch mechanisms inside the code. There's a little bit of a thing going on with replica sets and replication controllers. I don't know if anyone noticed that, but the attribute on the cluster is called replica set, but under the hood it's actually a replication controller, and we need to kind of like sort out that muddiness. We also want to add methods to things like replica sets, so you can just call scale without having to do some clever stuff with the patch call on the proxy. That's how I manage. If you look at the code, you'll see how that's done. Read the docs are also it's a work in progress. Sorry, I'm trying hard to finish the documentation, but it's always kind of like goes on the back burner. And I say the code examples for those scripts are all on GitHub, which is up there as well. Yeah, thank you. Questions? The reason why we wrote it wasn't for the fun of it. I work for Kube, and it's a SaaS monitoring solution that we started writing about 18 months ago. And we decided, because we'd never written a SaaS before, we thought, well, how are we going to do this? We thought we'd deploy it to GKE and GC GKE, so it's on the hosted Kubernetes on Google. And we wanted to, being a monitoring company, we thought, well, we need to monitor our stuff as well. So we wanted to start seeing what was going on inside the Kubernetes cluster. So we did. We started to use the CAdvisor API to see what was going on, and we used Kube to actually, look at because we write everything in Python, and we were using Kube to find out what artifacts there were in the Kubernetes cluster. And now it's almost like we started off writing a general purpose monitoring solution, but we're sort of pivoting now towards writing a Kubernetes monitoring solution. There's a couple of things out there that do it, but we focus on the topology and the relationships between things. So we build relationships between the namespaces and the pods and the containers that are running in the cluster. And we're actually currently working on also mapping relationships between nodes and services and endpoints and all that kind of stuff as well. Because, you know, managing a Kubernetes cluster, as we found out, is flipping hard. So we're using Kube and Anger, yes, in that environment. And yeah, so the features will continue to appear because we need them for our product. Hello. Yes. Yeah, Marathon's a framework that works with Mesos, and that's, and Kubernetes is actually an alternate framework for Mesos. So, yeah, Marathon is a container control plane, as is something like CoreOS's Fleet, which, you know, also manages containers. So, yeah, it's another one of those, but it's the best one. It's the only one you should use. Did that answer your question again? Yeah, well, I just wondered what's the difference between that and Marathon, because when you're talking about it sounds like... Yeah, okay. So Marathon something works differently. It still has a similar approach with, you know, there is some kind of daemon running on the node cluster, and the framework tends to do all the work. It's just that Kubernetes is more opinionated in the way it lets you define and work with your container cluster. So it forces you to do certain things. I don't know anything really about Marathon apart from its name. You know, the one thing I know about Fleet is it's sort of like based on System D, so it's kind of like a distributed System D, which sounds quite neat to me. So yeah, but yeah, they're similar, but they're obviously engineered by different people and they do different things, and they've all got their advantages and disadvantages, I'm sure. Okay.